Hello there, Mr. Sutton here, bringing you the Algebra 2 10-7 Part 2 homework solutions on using trigonometric identities. In this one, we're focusing on some identities that are going to require us to do a little bit of factoring first, and we have also some negative angle and cofunction identities. For this problem, one of the first things I notice here, I don't have any special angle things going on. I do have a squared trig function. So if I wanted to, I could immediately use a Pythagorean identity and swap this tan squared out for something. I'm not sure that's the best way to go, but it's an option. One other thing I notice algebraically is that we have two terms that both have a secant of theta in them. So I can actually do a little factoring here. I can take out secant of theta, and that leaves me with just tan squared plus 1. And at this point, I'm going to have to use a Pythagorean identity. We have the identity of tan squared plus 1, or 1 plus tan squared equals secant squared. So I can actually directly swap out this parentheses for secant squared. And then secant times secant squared of theta is just going to be secant cubed of theta. For this problem, going through my list of things to check in my APAC mnemonic that I use, that first A stands for angle identities, and we've got a pi over 2 minus x. This is one of our cofunction situations. So I can replace this with the cofunction for this with just the regular angle, the complementary angle. So we can replace this with sine of x. And at this point, I can turn cosecant into 1 over sine. And now if I same change flip this thing and multiply, I've got sine of x times sine of x, which will give me a final answer of sine squared of x. For this problem, I notice right away that I have a cofunction sort of situation going on with this 90 minus x business. So I'm going to replace cosine of this with the cofunction, which is cosine, or sine rather. So we're going to replace this with sine of just x. And at this point, I notice in my numerator, I can factor a sine of x out of those two terms. So that leaves me with secant of x plus 1. And doing this, I happen to notice that secant of x plus 1 and 1 plus secant of x, those are actually the same factor. So I can cancel those. And that leaves me then with the final answer of just sine of x. For this problem, going through my list of things that I try when I'm simplifying, I notice right away that we have an angle identity sort of issue going on here. We have a negative angle here. So I'm going to use my negative angle identity. I know that tan of negative x is negative tan of x. So I'm going to turn this tan squared of negative x into negative tan of x quantity squared. Now, once I square this, that's going to give me a positive tan squared of x. And there's a few options I have at that point, but since I've got all these different functions going on, I'm thinking I'm just going to turn that into a sine squared over cosine squared of x. I'm being a little bit strategic doing that right away, because I noticed that I had this cosine squared over here. So that's going to cancel out nicely with this cosine squared in this little mini denominator here. So that leaves me with sine squared of x minus 1 in the numerator. Now at this point, I'm going to take a look at my Pythagorean identities because I've got two terms up here with a squared trig function. So I have the identity sine squared plus cosine squared equals 1. Is there a way to rearrange this so that I have sine squared minus 1? Well, there is. If I subtract cosine squared over here and subtract 1 to the left side, sine squared minus 1 is the same as negative cosine squared. So that's what I'll replace this numerator with. And I've got a negative over a positive version of the same thing. So those are going to cancel, just giving me negative 1. For this problem, there's actually a fair amount of stuff going on. So just kind of going through my list of things to try. I don't see any weird angle stuff going on, but we do have a squared trig function up here, so a Pythagorean identity might help. We've got the identity cotan squared plus 1 equals cosecant squared. So I could, if I wanted to, replace this with something bigger that has cosecant in it. And the reason I might do that is I notice this cosecant in the denominator. So if I can replace this numerator with something that's maybe factorable, I might be able to reduce this fraction a bit. So on this identity, if I subtract 1 to the other side, I see that cotan squared is the same as cosecant squared minus 1. So I can replace that numerator with cosecant squared minus 1. And I'll worry about the rest of this expression in a little bit, but I want to focus on this fraction here. So this is actually an a squared minus b squared factoring situation. So I can break this up using square roots. I can do cosecant of theta plus 1 times cosecant of theta minus 1. And once I've done that, I notice that these cosecant of theta plus 1s are going to cancel. So that's good news. Now let's go back to this sine times cosecant business. Cosecant is actually 1 over sine. So this sine and this sine can cancel. And that means this whole second expression here is really just 1. So let's see what we have now that the dust is starting to settle here. I have a cosecant of theta minus 1. I also have a plus 1 just randomly there. Minus 1 plus 1 is going to go away. So that means I just end up with cosecant of theta for my final answer.